Worksheet 8A, yes. Got it? All right, so all we're going to do is these 6 application questions today. Are these 6? Anyway. We're going to need our calculator to be in sequence mode for some of them. The enrollment at Tennessee State University is currently 35,000. Each year, the school will graduate 25% of its students and then will enroll 6,500 new students. What will the enrollment be in 8 years? Okay, so what happens first? Okay, well, we do have this is the day when we kind of might want to use a sub 0 for some things. So this is in 8 years from now. So this is now, so nothing has happened. So maybe we should call it 0 years. So, because 1 year from now, some stuff will have happened, right? Yeah. So if we call that term 0, then we are looking for term 8. Okay, but the issue is that there's 2 things happening, and the order matters, okay? But the first thing happening is that 25% of the students graduate, okay? So how would we find that number? Who's going to be left? 35,000 times what? Okay, wait a minute. 25% leave. Yes. So Christian says, yes, 75% remain. So if we multiply 35,000 times 0.75, we'll get a number. And then onto that number, which is another 6,500 students will be added. Whoops, I can't write. So we'll be back up to 32,700. Okay, so this is going to be after 1 year. Now we could keep doing that by hand, but we could also do it on the calculator. Okay, on the calculator, we need to decide, can we write this as an explicit or recursive formula? Can we base it on a term number, or is it always going to be based on the previous term? Yeah, I think it'd be easier to write it as previous term. Good idea, Kelsey. So every term that we do takes the previous term, and what 2 things did we do? So we multiplied by 0.75, and then we did what? Added 6,500. So this process would keep doing that, right? Because it'll take the previous term and then it'll repeat that and repeat that. This is not arithmetic nor geometric. We're doing both multiplying and adding, right? Okay. We need to make sure it multiplies first, but will it automatically multiply first because of order of operations, right? Okay, so let's put this in our calculator, but what do we want to call the first term? We want to call term 0 3,500. Now, I'm a little 35,000, you're right. I'm a little nervous that it's not going to like this because 0 minus 1 is negative, but let's see what happens. So we're in sequence mode. We go to y equals. Do you have this disaster, guys? Okay, does anybody remember what any of this stands for? Okay, n min is the minimum term number. Oh, yes. No. It's the term number, not the value of the term. So we decided to call that 0. Now, fortunately, the newer version does this, which is great. My calculator right here would say U sub n min, which is kind of confusing, but it means U sub and whatever we put up here, which is 0, would be U n min, which means 0. So that's where we want to put in the 35,000. Okay. Now we got to put our formula back up here. What did we do? What did we write down? Okay, wait a minute. The recursive formula we rewrote down said take the previous term. How are we going to put that in our calculator? Do you remember? Anybody where we get the funky U? It's this little U above the 7 here. Does everybody see it? So we have to go second 7 to get the little lowercase u. And then you just put parenthesis and use your x, t, theta, n key to get n minus 1. And it knows that you mean that as a subscript. Yes. Yes, because all of these are, instead of a sub n, it's u sub n. Okay. You can use any variable you want, but the calculator uses u. Unfortunately, the CUDA worksheets that we've been using use a, so I've just been using either one. All right, what did we say to do to that term first? Times 0.75, and then add 6,500, and we decided we really didn't need parentheses because it was going to do this in the right order. Now, let's see what happens if we go to the table. I'm a little nervous. Oh, I'm way out here. I need my table to go back to term 0. Oh, I think it worked, yes? Is this what we had, 32,750? Okay. So the 8th year is what we were asked in this question, right? Now, I will show you that if you scroll down here to year 8 and over, it's actually a crazy decimal. But we want a whole number of students anyway, right? So it doesn't matter. 26,901 would be roughly the enrollment. So 8 years. It was 26,901. Okay, and let me maybe just, in case someone's looking at the notes, slide what we typed here down in this corner. Okay, everybody good? Oop, I don't know what I just bumped. All right, number 2 says the business makes a $10,000 profit during its first year. If the yearly profit increases by 7,500 in each subsequent year, what will the profit be in the 10th year? What will the profit be for, does yours have more? No. It just stops there? Yeah, I guess we'll just figure out the 10th year. Is this arithmetic or geometric? Yeah, they're just adding, right? I don't even think we need our calculator. We could practice with the calculator. But is this year 0 or year 1? It says it's first year. So yeah, I'm thinking we should call this year 1. I'll use U this time just because the calculator does, but you can use A, doesn't matter. All right. Every year, we could write arithmetic or, recursive or explicit here. Because starting with the first year, they're doing what? Good. adding a difference of 7,500. And how many times do we want to add that? Yes, 10 minus 1, or 9 times, and that would give us the 9th term. Should we put it in the exponent? Okay, we're just adding it on over and over. We're not doing multiplying by it over and over.
Okay.
It's not geometric. That's when it would be in the exponent. Good question. So it's just 10,000 plus 7,500 times 9. And I don't know what that is. That was the 10th term, not the 9th term. Okay, so year 10, the profit would be this. Couple things I want to add to this question. Could you write this as a recursive sequence? Can anybody figure out how to do that? Okay, and then, yeah, whatever. That it? Take the previous term, add 7,500, right? The first term was 10,000. But this is the formula for recursive. We would have, if we want, we'd have to keep doing it to get out to year 10. This was the explicit form. Let me just show you how you could have typed that in, okay? Explicit, remember? You would have said term 1. Well, you actually don't need a term number when you're doing explicit. Or you don't need a starting value. We just put in, was it 10,000, guys? Plus 7,500. But the formula was n minus 1. So you could put it in as an explicit formula, and then you don't need to enter. It doesn't matter if you're talking about term 1 or term 0. I can change this to a 1, but it isn't going to matter because I'm not going to enter anything anyway. But now if I go to the table and I wanted to know what they made the 10th year, I'd get this 77,500. Is that what we got? Okay. I just remembered what the second half of this question was about. Find the total profit for, can we find the total profit for those 10 years? What would we need to do? Oh, okay, we could find all the numbers in between and add them up, but does anybody remember what else? We have a formula. Yes, the sum of 10 years. And is this arithmetic or geometric again? Arithmetic, so what's the formula look like? Good job. The first year plus, oops, I shouldn't have given that away, but does anybody remember how it goes? Yes, the last year. I can. Yes. Do you have a sheet? Okay, because this is what happened last time and I didn't show up because I forgot. And she's writing herself a giant note. Okay. Yeah, check that there's someone in there. Last time I said I'd sub for Hardy. Yep, there was no teacher in there the whole hour. Luckily it was an honors class, or I'd probably be fired right now. Do you remember the formula? Look at the formula. We should probably write the formula on here. The sum of n numbers is the first plus the last times. Anybody remember how it goes? No. Look on your peach sheet. Arithmetic sum. You're on the right track. It's n divided by 2, but what's n? The number of terms, right? So it's just 10 divided by 2. Because think about it. If you add the first, if there's 10 terms, if you add the first and last together, there's going to be how many pairs of that? 5, right? Because there was 10 terms. So then we're going to, do you remember when we were doing the 1 to 100, you added them together? First and last always total the same. Okay. But because there's 10 numbers, there'll be 5 pairs of whatever that totals. All right. Someone get an answer? Times 5. Did you do that part? 10 divided by 2. What is it? 10,000 plus 77,500. You added and got 87,500, but then you didn't do times 10 divided by 2. Did you remember parentheses around the first two, maybe? Can you see what he did wrong?
I got 5.
We're making this question way too difficult. It's 10,000 plus no, it's 10,000. Okay, sorry video watchers who are now trying to figure out what the world is wrong with this class. 437,500. Okay, we could have found them all and added them up in a third of the time. Moving on to number 3. A lecture hall has 6 seats in the first row, 8 seats in the second row, 10 seats in the third row, and so on through row 12. Then rows 12 through 20 all have the same number of seats. Find the total number of seats in the auditorium. It's not, because it only goes to 12. I have it written as though it's infinite, yes. But is this arithmetic or geometric? We're multiplying by something?
Oh, no.
There we go. It's arithmetic because we're adding what? Every time? 2. So can we find the 12th row?
Yeah.
Okay, so the 12th row should be the first row plus the difference, 12 minus 1 times. Okay, what will that be? What's the difference? Or 11 times, which would be 28, maybe? Someone get 28? Okay. Now, if we're going to eventually need to find how many seats that was altogether, right? But how many more? We got to be careful. If we count row 12 there, then we can't count row 12 again, right? So how many more rows are there? 13, 14, 15, 16, 17, 18, 19, 20. There are 8 more rows. Everybody good? Okay. And each of those rows will have what? So we can figure that part out pretty easy. I can't, but I hope you can. 4, 2, what? Okay. That's for rows 13 through 20. That's the total for those. How are we going to find the total for the first 12 rows? Okay, we have a better idea. What kind of formula did you say it was? Yes, what is this formula? Is it Sum of the first 12 would be the first one plus the last one times 12 over 2. There you go. So 6 plus 28 times 6, or 34 times 6. Yeah, that's the sum of the first 12 rows. So the total is the 224 plus 174, 398. Yes, it does. But see, we counted the 12th row here, so we didn't want to count it again. Yeah, we were just being careful, but I think we did it right. Yep. Okay. I wouldn't put one that tricky on the quiz, but it wasn't that bad, right? Okay.
Where are you getting it?
34 times 6, is that not 174?
Yeah, I got
Oh, so you guys are telling me wrong numbers? Great. I'm going to have to redo this video. You guys are not 204, yes?
Yeah.
So then it was 204 plus 224 is 428. Now I switched colors, but all right. Yeah. Maybe I'll just post a Bruzo's video and be done with it. All right, number 4. Love this question. If you're paid a penny on the first day of March, 0.01. On the second day, you're paid 2 cents, 0.02. On each day your salary doubles, so the next day you'd get 0.04, 0.08. Okay. First of all, is this arithmetic or geometric? Geometric, where what? R is 2. Okay. How many days in March? 31. Okay. So let's just figure out what you'd make on the 31st day. How do you look at your sheet? What's the formula for a geometric sequence? Okay. So we want to put in what? 0.01 times 2, 31 minus 1 times, or 30 times. Okay. So day 31, you make how much? We did change it to dollars, by the way, because we made it 0.01. Read me that number. Okay, just read me digits. 10, 7, 3. Someone else get that? Okay. That's just the 31st day.
over here.
It's ridiculously small to start. Okay. Let's let the calculator generate the sequence so that we can actually see when it starts paying. How's that sound? So since we're just blowing this video off anyway, go ahead. How would we put this into the calculator? Do you remember? Are we going to can we put it in as an explicit formula? That's what we just wrote, right? So the first day we're going to just put 0.01. Well, I'm putting this in as the formula, so I don't need to worry about whether it's term 1 or not. Times 2 to the power of just n minus 1, right? Okay, now let's look at the sequence in the table. Look, we ain't making diddly, right? Until where? Where does it really get interesting? Okay, somewhere in here, it's like day 18, just for that day, you make over $1,000, right? And then it gets really exciting. Like day 21, you're making 4 digits a day. Okay. All right. But what did the question actually ask now that we saw that and we're really excited? So what do they really want to know? Yes. So how are we going to do that? Yes. What is the formula for a sum that is geometric? It is first term. Do you remember what I said though about this? You should be careful to put extra parentheses around R. It actually isn't going to matter because R is just a number 2 this time. But just to be careful, we usually do first term 1 minus the ratio to the, what's n? That's term 1. What's n? N stands for term number. What is the term number we're adding up through? Yes. And it's not 31 minus 1, it's 31. We want to make sure and count that 31st day, right? Because it was a doozy. All over 1 minus 2. And in this case, because 2 is just a positive whole number, you really don't need those extra parentheses. .01 times 1 minus 2 to the 31 divided by 1 minus 2. Anyone else get 21 million and change? Might make a charitable donation with the change, I don't know. So the total sum for all of March, let's see if I go back here in my free space. The total sum is 21. How much, guys? Can you read me the digits after the 21? Okay. Lovely. Yes. Yeah. Everybody good? Okay. You feel like you're reviewing your formulas a little bit, hopefully? A monument is constructed by laying a row of 60 bricks at ground level. Okay, so we're going to put 60 on the bottom level. There's 60 bricks down here, okay? A second row with 2 fewer bricks. So on top of that, we're going to put, and it's going to be 58. So the terms are going 60, 58. On that, a third row with 2 fewer bricks. Dot, 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 dot. The top row has 10 bricks. Oh. Do we know how many rows there are? Can we figure out how many rows there are? How are we going to do that, Keaton? First of all, arithmetic or geometric, so we know which formulas we're looking at. Okay, arithmetic. So to find any term, you take the first term and add the difference n minus 1 times. What are we going to do, though? Okay, eventually we want the sum, but the sum says we have to know the first term, the last term, and the number of terms divided by 2. We know the first and last term, but do we know how many terms that is? How many rows? We got to figure that out. So what are we trying to find? What letter? N. Okay, so can we put stuff in this formula to find N? The last term is what? Nope, 60 was the first term. So 10 is the last term. What's the first term? And the difference is -2. N minus 1 times. Okay, can you solve that? If you want to distribute, you can distribute. If you just want to work backwards, that's fine. I'd probably be lazy, go 10 minus 60 is -50, then divide off the -2 and get 25, add 1. I got 26, but can you do it however you want and see what you get for N? Kayvon, you working on the algebra? No? Yes?
Oh, no.
He's honest. Always. Kat, did you get 26? Okay. Now what, guys? We still have to find all the bricks. So what do we have to do? The sum of those 26 rows would be, what's the first row? 60. The last row is 10. How many rows were there? 26 divided by 2. So 70 times 13, 910? 910 maybe? That's what half our brain says, yes? In the old pre-calc book, this was lesson 3 at the beginning of the year. What?
I mean, it is.
Okay. We've been at this for how long and we still have one problem left. It's pretty challenging for the first week of school, let me tell you. Tuition at a university is now $3,000 per year and will increase $150 per year in subsequent years. If a student starts school now, spends 4 years as an undergraduate, 3 years in law school, and 5 years earning a PhD, how much tuition will she have paid? Okay. So the first year she pays how much? And it goes up how much? Okay, so is it R? Okay. It is arithmetic because we are adding. Oops, I thought I had my eraser. There we go. We are adding this, so that's what? For the next term, yes. But the difference is 150, right? Okay. Starts school now, spends 4 years as an undergraduate, 3 years in law school, and 5 years as a PhD. How much tuition will she have paid? Okay, so how many years is she going to go to school? 4, 3 is 7, and 5 is 12, right? We're good? Okay, so she needs the sum of 12 years, yes? What kind of a sequence is this again? Yes, so what does the formula look like for finding the sum? In our case, the 12th term, right? And n is also going to be 12. So 12 over 2 times the first term, which is 3,000, times the last term, which is to be determined. How are we going to find the last term?
The first term.
Go, Kelsey. So I don't know what that is. What's her tuition the final year? Okay, so this is the last year, her tuition. So what did she pay for all 12 years?
$45.
That would be the cheapest PhD ever earned, I think. That's a pretty low tuition, huh? Especially to only go up by $150. Anybody know what percent that would be? 150 divided by 3,000?
Oh, wait.
0.02? Is it just 2? Yeah, because 10 would be, no, it's 5, isn't it? 5%? Yeah. 5% increase per year is probably not, yeah. So would we like to do this question over with more realistic numbers?
No.
Possibly not. All right. That's it, right? Is that 8? Okay. So we survived. The video is extraordinarily long and wrong and many other things.